Okay. Good afternoon, everybody. Today we'll be talking about catalog services and open source geonetwork. Well, this particular topic, in fact, talks about the services which somebody wants to host through their network, and they can also be a part of a bigger network. So basically, catalog services is being used worldwide, and whatever the geospatial data which has been created by various organizations, they wanted to get it consumed by different networks. So we'll be talking in detail about that. And there is an open source software called Geonetwork which provides to build any in fact, it's a platform which allows you to build these type of network, and it can allow the interlinking of those services. So we'll be talking about these catalog services in this 1.5 hour session. Well, I have planned my presentation with the like I'll be talking about the background, then how this catalog services have been evolved because of the spatial data infrastructure. I'll be quickly touching upon those aspects, and then we'll quickly jump to the evolution of GeoNetwork and the overall concept and how it is being used by various international organizations. And then we'll be sharing one of the small case study which IRS has undertaken, and in fact we'll be sharing what all data sets we use it for this catalog services. To tell you, to begin with catalog services, how this particular concept has evolved. In fact, if you see the overall information systems which are available worldwide, they have been classified into two categories. One is a centralized information system, which is totally based on the centralized repository. Like, for instance, in your organization, if you want to host your data, so and you know that you are the only wholesale agency which generates the data, and you wanted to host it. So for that, if you want to build an information system, that information system will be more of a centralized, or I would say a centralized application, wherein you are disseminating the data, or I would say you are providing the services on the basis of the data which is available in your server. So that is a centralized concept. Second thing is the decentralized category, wherein the n number of organizations want to host the data, they want to retain the copyright, and they want to put the services in the public domain. So for that, those type of concept is called the distributed or a decentralized application. So basically, in order to build the distributed services, we have to take care of two concepts. One is the interoperability, another one is the standards. Interoperability means that if there are two information systems, they can be interoperable to each other if they are able to access the services, or I would say they would able to transfer the metadata seamlessly, they can transfer the data seamlessly, and they can even transfer the functions seamlessly. Only then the two information systems are interoperable. So whenever we talk about distributed systems, they have to be interoperable. Means whatever the data, or whatever the functions, or whatever the utilities which are available in one information system, that can directly be consumed by the another information system. The another thing, and that is only possible if you are able to make use of the standards. Now, if both the information systems are using the same standards, they will be more interoperable to each other. So in order to basically achieve the distributed systems or a decentralized system, you have to have the interoperability between the different systems, and also the standards. That is, you have to adapt certain standards by which they both, or I would say n number of systems, can shake their hands. So that is the most important part of a decentralized system. So basically, an spatial data infrastructure is a concept wherein everybody, like maybe what I can say, like let us talk about the country like India, where a lot of data sets are available by different organizations. Means they are generating n number of data sets. Like Forest Survey of India is generating forest cover map. Central Soil Water Conservation is, or I would say National Bureau of Soil Survey is generating soil map. Similarly, you have Geological Survey of India, they are generating the geological map. So every organization is generating their own data sets. So as a user, if I want to consume the services from each one of the data providers, I should make use of a concept called spatial data infrastructure, wherein every organization who is generating the data has the copyright with them, and they can allow the services which can be interoperable and follow common standards. So basically this SDI talks about the technologies, the policies, the standards and the human resources necessary to acquire, process, store, distribute and improve the utilization of geospatial data. So rather than making a centralized repository, I would prefer that the data comes into an SDI, because as an individual, if I want to share the data like a stakeholder, I can even provide one of the input for the spatial data infrastructure. So I think in my subsequent slide, the clarity will be more. So basically, spatial data infrastructure allows the organizations and individuals cooperation. Basically, it is using the web technologies, the ICT, or the geoinformatics to share the geographic information, and that is only possible if you are following certain set of standards. And then and also the thing is, if I become a stakeholder, if I become one of the contributor, I should know that the type of data which I am providing under spatial data infrastructure should be common theme, means it should be utilized by the people rather than a specific data which I am generating. Like for instance, Survey of India. Survey of India is involved in the generation of the boundary of the country, or I would say the boundary of the states, or the village boundary, everything. So they are the people who are responsible for giving the boundary information. So if I am the user, I cannot generate my own boundary. Ultimately, I have to use the authentic source. And this authentic source becomes the common base information, which can on top of it I can build the detailed information. So common base theme of the data is the most important part of the spatial data infrastructure. So together, with the help of the organization, with the help of the stakeholder, with the help of an individual, we can create the network of organization and unified collection of data to ease decision making for common pieces of geography. What I mean to say is that if there are organizations who are providing the base theme data, why I should generate the data again and again? So the basic objective is that the redundancy of the data will be totally removed, and also the authentic information will come to the user. So that is the most important point. So rather than reinventing the wheel, it is better to make use of the existing data in the form of services, and then I can build on top of it. So the most of the time, rather than creating the data, I can spend most of my time on the analysis part rather than generating the baseline data. So that is the mechanism by which the network of organization can come together, and by this the most of the information can be used. Now there is one very important slide which I am trying to show is there are two mechanisms by which you can share or exchange your geographic information. On one side, what you see is where there is no concept of SDI. People are sharing the data through checking that whether like suppose if I want to search the forest data. Now forest data for individual node, I am going and checking that whether the forest data is available or not. But that is the mechanism of n-1. But if you see on the right hand side, the red one, the middle, you see the regional SDI, which is nothing but the gateway. It's a clearing house which will help you to search the data, and then that whatever the search you provide on the system, you will be directly redirected to the specific node where you are looking for. So basically in the regional SDI mechanism, your search is 2n rather than n-1, where you don't use a regional spatial data infrastructure. So basically you are trying to have the minimum search which is required, and then you can be directly redirected to the node where the actual data resides. So that is the mechanism which tells you that, like suppose if n is 10, so the 2 into 10 is 20, so means 20 permutation combinations are there, whereas in the other one there will be 90. So you can see that if you have the regional SDI within the organization, or I would say within the country, the searching mechanism will be less, and the people can be directly redirected to the node where the actual data resides for a particular search. Now the entire SDI is composed of certain components like clearinghouse, metadata, geospatial data, partnership, standards. All these elements are considered to be the components of spatial data infrastructure, and they are linked in a very explicit way to assure the function of the enterprise. So basically what you see is that you have standards, you have to follow standards if you want to make interoperability among the various networking organizations. Then you have to have a geospatial data. Means whenever I talk about geospatial data, I am talking about the framework data. Framework data means the common base theme data on top of which you can build your own application, like forest cover map or Survey of India map or geological map. On all these maps you can build your own data, or you can build your own application. So geospatial data is nothing but the framework plus geospatial data. So basically geospatial data is talks about the common base themes data. Then the metadata. Metadata is, I would say, is the most important part. I would say it's the building block of any SDI which is using the catalog services. So metadata means, you might be aware of this particular term. This is quite familiar term. Metadata is nothing but the data about the data. So there are certain standards which are available globally by which you can build the metadata of a particular raster data or a vector data. So and there are, if you happen to see any of the GIS software, you will see that there are so many standards which are available to build the metadata of a particular raster or a vector data. I would say the time taken to fill all the elements within the metadata is more time consuming compared to actually generating the raster or the vector data. So what I mean to say is that the fields, the elements which are required in metadata are exhaustive. So in order to, so it's not possible for all the organization or for all the individual to fill all the metadata elements. So what they do is, there are few mandatory elements which one can fill for the particular vector or raster data, and that can serve the purpose. And then the clearinghouse is nothing but it is called as the gateway, or I would say it's a front end of a portal which allows you to search the data, and that searching will be totally based on metadata, and the data which you are providing, that is the geospatial data, the framework data, is available in the server, and you are providing the WMS services, or you are providing a different online resources, and they are directly making use of standards. So what I mean to say is that it's a holistic approach by which you can build any spatial data infrastructure. So you can see that the role of clearinghouse is like a regional SDI, which is nothing but the portal, front end portal, which allows the discovery of the spatial data. Discovery of the spatial data means, like if there are 10 nodes, all the nodes information, I would say the marketing, or I would say the advertising portion, is there in the front end of the portal. So there, like suppose if I am hosting some forest classification map, or I would say some thematic map, that type of advertising I can do it on the portal, so people can attract, and from there it can be redirected to the actual services wherein I am hosting all my data set, like the services. So I am one of the node of the entire data. So discovery one can do through clearinghouse. Distributed search for all the different type of keywords can be done. There is a uniform interface for all the searches, and the advertising. So advertising for your data holding. So all those things is possible through a clearinghouse. So you can see that partnership clearinghouse is nothing but the catalog services. the metadata, framework data and the standards. Everything is joined together in order to build the spatial data infrastructure. So that is the overall mechanism why this particular SDI is taken a very important role in the field of geospatial. In most of the countries, I would say that they are trying to build NSDI, and in fact NSDI total is totally hierarchical in structure. If you start from the base, it is LSDI, local spatial data infrastructure, then it is I would say state spatial data infrastructure, then national spatial data infrastructure, then comes the regional spatial data infrastructure, and ultimately it becomes a global spatial data infrastructure. So the entire hierarchy of the SDI is available. If you start building your lower hierarchy, then automatically you can build the different level of hierarchy and you can reach to the global spatial data infrastructure. So that is the mechanism which is followed under the spatial data infrastructure. So now in order to any organization, or I would say if there is a set of organization and they are working on certain projects which they want that the data can be shared among themselves, and also there will be some exchange mechanism, sharing and exchange mechanism is there. You can build your spatial data infrastructure by using one of the open source called Geonetwork. In fact, this Geonetwork was first developed by FAO, Food and Agriculture Organization. There was some project, there was some requirement, so they developed this application and as per their requirement, and with that application this entire product came into existence under open source, and it is publicly available. So basically, like suppose if there are 10 nodes and they want to establish an SDI among themselves, they can build it. That is only possible if you have the data. Those all 10 nodes have their own data, but they should also have the metadata of all the data sets. So once these metadata sets of the distributed nodes are available, you can develop a spatial data infrastructure. In fact, in the university systems, if you want that there should be some mechanism within your intranet, you want to exchange some of the spatial data, you can directly do that by making use of this Geonetwork open source. And in fact, it is one of the most user-friendly software. You don't need high programming skills to really set up this particular open source and you can build your own portal. So that is the beauty of this particular Geonetwork. So it is basically, it is a standard-based decentralized. I want that you should see this term called decentralized spatial information management system. It is designed to enable access to georeference data and cartographic products from a variety of data providers through descriptive metadata. So what you have to do is, as a node, you have to provide the metadata of your data, and that metadata resides inside the portal. So it's not the data which is the actual data. The actual data lies in the node. Only in the portal, only the metadata resides. So that it is nothing but the catalog registry of all the metadata which is available through the distributed nodes. So basically, that is the way the sharing mechanism of different organizations take place. And the main goal of this Geonetwork is to increase collaboration within and between organizations for reducing duplication and enhancing information consistency and quality, and to improve the accessibility of geographic information along with associated information organized and documented in a standard and a consistent way. So basically, it allows you to build a portal, and this portal can be you can link to n number of nodes if it follows certain protocols. So there are certain features available in Geonetwork open source. First of all, instant search on local and distributed geospatial catalogs. Now here the searching mechanism is very powerful. Basically, it uses a distributed protocol called Z39.50. It is a protocol which allows you to do the distributed search, and also it accesses in a very limited time. It can provide you the result. So it can work on both local and distributed data sets. Then uploading and the downloading of the data is possible. then you can also link this the port. You can link this GeoNetwork portal with WMS viewer. That is, whatever the WMS services which have been provided through online resource by the different nodes can directly be visualized on top of the Google Earth, or also what you can do is you can make use of Bhuvan WMS satellite data services, and on top of it you can directly display your data sets. So that is an interactive map viewer is available within GeoNetwork. Then online editing of metadata is already available. Then harvesting. So basically, when this particular GeoNetwork was first tried in Africa, in fact, in Africa, most of the organizations they lack 24/7 internet connectivity. So this particular portal worked in a very efficient way, because what it does, it uses a MAC ID of a particular system which is providing the updated metadata. So what it does, it search for the distributed data. If there is any change in the data, because MAC ID, there is 16-digit ID is there, and there is a date with the MAC ID. If the date has been changed because of the updation of the metadata, then automatically it is taken care by the harvesting mechanism. If there is no change, because if the date doesn't change, it means there is no updation of the data has taken place. So that harvesting, scheduled harvesting of this particular GeoNetwork makes it more efficient, because even in the offline mode, maybe at last week, if the network was working, it updates the data and then it stops. So that is the way the scheduled harvesting mechanism takes a very important role in order to update all the distributed nodes data within the portal. So you can have the group and user management is also there. Fine-grained access control is also available. Just to tell you that the evolution of GeoNetwork took place in way back in 2000. Almost 15 years have passed, and you will be surprised to know there are many organizations who are using. I would say that it's more international organizations which are trying to work on this particular GeoNetwork. So you can see that WFP, UNEP, there are so many other. So presently the version which is available on internet is 3.0.2, and it is highly it is more simple, and in fact a lot of updation has taken place. You can see the users are United Nations is there, then FGDC, JRC, most of the big organizations they are using the GeoNetwork, because they think that the simplest way to monitor their projects through their different nodes is this particular portal, or I would say the GeoNetwork. And then the individual project like Europe, America, most of the countries are making use of this. And I would say that around 500 more members are now making use of GeoNetwork and providing their feedback on regular basis. So the overall functionality is the searching of the spatial data and services, downloading of data is possible, online dynamic viewing of the OGC WMS services, metadata editor, user management, and then of course synchronization, that is the distributed search, which goes on updating on the basis of the harvesting mechanism. Now this entire GeoNetwork basically make use of standards. Now whenever I talk about standards, the standard which is available for the because GeoNetwork basically uses the metadata, and this metadata has got certain standards given by ISO, that is the International Standard for Geographic this thing. So basically they have one working group wherein the TC 211, it's a technical commission where the metadata standards has been defined, and it comes under ISO 19115. You will see that whatever the standards given for any of the raster or vector data is given under ISO 19115. And then the second part is the Open GIS Consortium standards, wherein you use WMS services or WFS services or even WCS services. All those services can be used through GeoNetwork. So here, as I already told you, that the entire GeoNetwork is totally based on descriptive metadata, and that descriptive metadata can be generated by the existing ISO standards. like ISO 19139 it talks about the identification, extent, quality, spatial, temporal schema, spatial reference distribution. All those things are some of the elements where you have to fill all the information of your geospatial data. So there, after filling that information under ISO 19115 or ISO 19139 or FGDC or Dublin Code, there are some 4 or 5 standards which are given in Geonetwork, which and this particular standard will allow you to create the metadata of any of the raster or the vector data. And then implementing this common standard. Once these standards have been implemented, whether you talk about WMS services or you talk about metadata, you can describe the data, you can find the data, and you can combine the data. This is the overall concept of service-oriented architecture, wherein you can find, bind, and describe. Everything is possible by making use of those services which are available through Geonetwork. So there is a good example that there are few Geonetworks which are installed across the different organization, and they can even talk to each other because they are having their metadata catalog, they are having their distributed services, and all these networks can be combined together in order to have the accessibility among various existing Geonetwork portals. So you can see that here UNEP portal is there, FAO portal is there, Asia Coverage, they all make use of this Geonetwork. They have the metadata catalog, they have these WMS services, they have the data, and they can directly do the searching and they can access the services which are available. So you can see that a portal, you can like suppose as a node, I can provide the WMS services. Those WMS services can directly be accessed through Geonetwork. And even if you are providing some data services, that can also be provided through this Geonetwork portal. And then the catalog services. So catalog services are already available. They can directly be integrated into a geospatial portal, and every information can be directly, or I would say seamlessly, accessed by making use of this particular architecture. So this is the overall Geonetwork architecture. If you see down below, you can see that these are the ISO standards which I was referring, the ISO metadata standards, which is ISO 19115 and then ISO 19139. These are the two metadata standards given by ISO. Apart from this, there is also one standard called FGDC, which is also available. Maybe in this standard you can even find it in ArcGIS. This standard is quite common. And then DC is a Dublin code. This is another standard which allows you to, even if you want to put some other data apart from geospatial data, that data will have the metadata, and that metadata can be built by making use of Dublin code. Dublin code is a very simple metadata standard which has got very limited number of elements. You don't have to fill the exhaustive information. The exhaustive information only comes in ISO 19115 and ISO 19139. Then the second part is the exchange format XML. I was telling you in my second slide that decentralized data or a distributed data, you need to have the interoperability and you need to have the standard. So that is only possible if there are two information systems. They have been, one has been used, one is using Microsoft, another one is using Java or some other platforms. So if all these, they get, your entire information get converted into XML, which is considered to be an interoperable standard, which anything, whatever you develop, once get converted into XML, it becomes interoperable on the web. So that is the beauty of the metadata meta language. XML is called an extensible markup language, which is nothing but a meta language. You can generate geographical information, like for instance, if you want to send your actual data from one system to another, the vector data, it has to be converted into XML. That is GML, geographic markup language. The similar way, whatever the metadata which has been converted under this particular this thing gets converted into XML DC, XML FGDC, XML ISO 19139, 115. After that, it goes into the catalog access mode. Means these are the mechanism by which the distributed data can be accessed. So these are some of the protocols which have been used to do the searching across the distributed nodes. So any system which uses these protocols, Z39 or CSW or OpenSearch or OIE or GeoRSS, they can directly be accessed through this GeoNetwork portal. So once these systems are available, one can access all the data sets and they can be consumed among the different data providers. So utilities, you can search in the GeoNetwork node, you can do the synchronization, you can do the harvesting, all those things can be done, and you can even customize your catalog. So basic thing is GeoNetwork, the entire GeoNetwork software which is available, since it is open source, it can be customized as per your requirement. So it's not that you have to retain with the same the same template which is available within the GeoNetwork. So the searching is, you can do the searching mechanism in GeoNetwork is very strong, because it allows you to search on the basis of keywords, it allows you to search on the basis of the maps, that is the spatial search is there, then the keyword search is there. Another one is on the basis of the time, that is the temporal dimension. You can even search the data, like suppose if you want to search the data which has been generated in 2005, so automatically it will search from all the distributed nodes, check the metadata when it was time stamped, and on the basis of time stamp automatically it will retrieve the data which can be used. So you can see that title, abstract, keywords, exact search, bounding box, you can even create your own bounding box, and apart from that bounding box you can even fire a topological relationships, like you can fire the topological relationships, means overlap, meet, all those type of relationships in order to search a particular services. So those type of mechanism allows GeoNetwork more powerful compared to other. So I was telling you about the harvesting. Basically it is a method to retrieve collection from different node based on the criteria. So advantages is faster than remote search. As I told you that it uses a MAC ID, and it also uses the timestamp, and and then it checks whether if the timestamp has been changed, then it automatically goes there, update the data, and then comes back. So that is the mechanism it does this. So once that because once it checks the updation, the entire data resides in the local server. So when you search, you will think that the searching has been done all across the distributed. No, it takes the updation information in the system, and then the entire metadata repository is available. It does the search, and then it redirect to the online data which is available in that node. So that is the thing which it does across different this things. So there are some sample configurations, like GeoNetwork node synchronization is there, then web dev, harvesting, all those things are available, and one can these are all sample configurations. Then the harvesting mechanism, basically what it does is, whatever the data you produce, the entire the harvesting mechanism is based on XML. So what it does is, once your building blocks is the building blocks of the metadata is created, it gets converted into XML, and after converting into XML, there is a MEF format, that is metadata exchange format, is used in order to do that harvesting and synchronize. So XML metadata privileges, thumbnails, data, everything is it consists of the entire this thing. So even if you have not generated, like if you doesn't want to generate the metadata of a particular raster or vector in the GeoNetwork, what you can do is, you can bring the MEF format from any of the native GIS software, and you can you can insert that particular MEF file in the GeoNetwork with respect to their particular raster or the vector data. So the customization also, there is the CSS file is there, you can customize it as per your requirement. You can change the images, you can change the entire look and feel of the GeoNetwork. And there what it does is, the entire XML request is being converted into HTML. So for that transformation, it uses XSLT in order to give the better result for the user. So there are few advantages conclusions. There are few conclusions like what is it? It's a geo portal. Geonetwork open source is a geo portal. You can quickly set up a metadata portal. It implements the ISO standards for the metadata like ISO 19115 and 19139. It allows online maintenance of metadata and data. So this is one of the conclusion. The second conclusion, anybody in the world that wants to set up a spatial data and metadata portal can do so. So if you want to make a geospatial geoportal, you can easily do it by making use of Geonetwork open source. No cost is involved in buying the application. Access to all the source code is available since it is open source. The entire code is available. You can easily modify the application, and that application can be put in the public domain so that people can make use of it. You can add new features to it. You can add new applications to it, and since you can do a lot of modifications, it comes under the GNU library or a lesser general public license, which you have to keep the respect of that particular licensing scheme which is available in Geonetwork. So there are few references which are available. You can quickly search to these references and see that what all applications are available. So I'll just quickly show you the step by step how you can install this Geonetwork open source, and then I'll be sharing you the application which has been developed. So localhost, once you start installing this software, so there is a installation setup is there, then searching mechanism is there. What, where and when, then spatial search, metadata standards, metadata creation, administration and customization. So you can download the Geonetwork application, then you can run the installer. The one very important thing is here you can the Geonetwork has inbuilt one of the RDBMS that is called McCoy database. So it is one of the RDBMS which is being supported by Geonetwork. So if you don't want to use the McCoy database, if you want to use PostgreSQL, or if you want to use Oracle or any of the RDBMS, it allows you that utility that you can migrate from McCoy database to a PostgreSQL or this thing. So in order to do that, there are certain the platforms. Ghast is one of the application which has been developed, which allows you to migrate from one system to another, and also it allows you to take the backup of the entire Geonetwork. So in that way it is quite comfortable and it is quite easy. So this is the way you install the entire Geonetwork. So these are some of the files, like there are few Java clients, and then there are documentation files are there. The web application is totally under web, and then the administrative tool, the Geonetwork administrative survival tool, that is Ghast, is available into this folder. So you can easily install this, and then this Geonetwork also provides you the different style sheets. You can directly work on styling, and then you can, if you want to change some of the styling, can even be changed. And after that, one more thing is the Geonetwork also provides you in different languages, because as I already told you that this particular software has been used by United Nations, it has been used by FAO, in fact developed and used by FAO and other international organizations. So that's why it uses all the international languages. So if you want to develop in English or Spanish or French or whatever it is, so it allows you a mechanism that it becomes more multilingual towards the international languages. Then the searching mechanism, which I was telling you, that there is a small window. Here you can see that the spatial search is available. You can see that automatically once you search this particular the thumbnail will come, and then this particular the information about this particular map is available. This is entire metadata is available, and you want to see the descriptive metadata, you can directly click to this, you can get all the descriptive information. So this is more of a spatial search where you are making a window, and on the basis of that window, that whatever the spatial extent which comes under this particular window, automatically that those maps or thumbnails or online resources will be available to the user. Similarly, the entire spatial search, you can see that I am presently searching on Africa, then automatically whatever the nodes which are providing the African related information will automatically be highlighted, and you can see that this is the thumbnail and this is the entire metadata information of that. Then this is the metadata visualization. Once you search for this particular Africa, you can see that this particular data is available, and this is the entire metadata of that particular information. Then you can also do the administration. You can change the privileges. You can give some type of rights to a particular admin. So all those type of administration is possible, and in fact understanding is very simple within this. So here I would like to show you one of the template which is given within the Geonetwork, that is FGDC template is there. You can see that all these red are all mandatory. You have to fill the information, but the remaining like non-red is not mandatory, means even if you leave it, it is not going to affect, but the red one has to be completed. Like suppose if you see the entire metadata element, there are around I would say 30-40 elements which are available. So but it is not mandatory that you have to fill all the elements or a sub element. So within that there are some 8 to 9 sub elements which provide which is mandatory. So these red one is nothing but the mandatory elements which has to be filled whenever you want to put them into web. So this is the way you can put, and then you can put the thumbnails, everything, and then once that is there, you can even import this from the metadata exchange format, and it can directly, you don't have to create the data, the metadata file here. You can even bring it from any of the GIS software. And then the harvesting concept, anyway I have explained you earlier. So whenever you want to do the harvesting, suppose you have connected to 30 nodes, so you have to give all the detailed DNS information of the harvesting node in this harvesting this thing. So once it is available, you have to check the updation. You have to do the updation with the DNS nodes, and then once the harvesting is done for all the nodes, you have all the updated information which can be used for searching. So this is the system configuration. You can provide the system configuration. If you are working in intranet, you can provide the private IP, but if you are working in intranet, then you have to make use of the public IP so that it can be accessed and all the nodes get connected. So one of the case study which is available within IARS, and we have in fact one project called Indian Bioresource Information Network, which is a distributed portal wherein the data from different networking organizations are coming, and we are generating the web services of that particular data sets, and after that this data can be accessible through a searching mechanism. So this is a little bit more about the distributed data sets, so I will not go into the details. This is the overall conceptual flow of the Indian Bioresource Information Network. So this is the spatial node which is working with some public IP, and then you can see that we have, because this entire whatever the work which we have demonstrated is within the country. So here you can do the searching, and all those searching is possible through spatial search, or you can even give a keyword like biodiversity, or you can give some other type of keyword which has got the distributed data within this. So this is one of the mechanism by which you can do the searching. So another way is you can directly open the map viewer. The web map viewer is available within the Geonetwork. So you can see that this entire customization has been done by us only, and in fact the metadata which we are using, we have not used ISO 19139 or 115. What we have done is we are using the NNRMS standard template which we have designed, and that template was integrated into this particular Geonetwork. So that is the way you can directly open these services, you can see that presently I am displaying the Bhuvan WMS services of the satellite data. And after that, on top of it, I have even displayed the points, the sample points which have been collected under this project is available, and then it can be overlaid on top of the on top of this data. So you can see that all these points are available, and one can even get the information related to these points. And after that, what you can even search the whatever the information with respect to those sample points. You can directly get the attribute information. So all those things I am doing it in the WMS viewer. So basically the GeoNetwork not only provides you the searching mechanism, but also the WMS viewer, which can allow you to integrate with any of the WMS services which are available worldwide. So it is not that only some of the services can be opened, but also you can consume the other services. So you can see that here I am displaying the vegetation type map of the entire country, and that is overlaid on top of the Bhuvan portal. So similarly, you can get the legends, all that information you can get. Similarly, this is the vegetation. This is the vegetation. Earlier was the land use land cover map. So all these WMS services which are already available in Bhuvan can directly be accessed in any of the WMS where given by the GeoNetwork. So you can see that this is the land use land cover map. Similarly, this is the fragmentation or the disturbance index. All these different types of maps are available through these WMS viewer. So this is the Bhuvan which I was telling you. You can the entire satellite data is available, and you can access all these data sets. And this is the another map of the LUSC 250,000 K map. All those things. So what I mean to say is that the GeoNetwork provides you to build the portal. It provides you a searching mechanism by which you can search the distributed data sets, and after that you can even allow the different WMS services which are available not as a part of distributed node, but other nodes. This thing, if you are aware of the WMS URL, you can directly open them and you can allow them access. So that is the mechanism by which you can build your SDI. And I would say that if you don't want to do customization, you can build this type of system within a week. Only thing is, if the data sets are available, your networking partners are available with the spatial data, you can easily establish this portal within a stipulated time. You don't have to work hard to really do the hard coding. So it is highly simple, and one can easily generate this type of this thing. So with this, this I complete my lecture on this GeoNetwork open source.